Hi, I want to go over an example of using the binomial probability distribution to calculate a probability. Remember, in our previous lecture, the binomial distribution arose in scenarios when we had a fixed number of trials n. Each trial has one of two outcomes, success or failure. Each trial is independent, and each trial has probability of success p and failure 1 minus p, called q. And the random variable, very important, the random variable counts the number of successes out of the fixed number of trials n. And if we have all of that, then we have this probability density function to calculate probability if all of those conditions are met above. Well, let's consider this example. We have a shipment of 100 parts. To make sure we have good product, we have a quality control engineer that inspects 10 parts out of the shipment. And the shipment will be rejected if more than 2 parts are found to be defective. Now, one more piece uh, of, of information here is that the overall defective rate is probability of defective equals 20% or 0.2. Here, x is going to be the number of defective parts out of 10. So already I've set up my random variable to correspond to the binomial distribution. X is the number of successes out of a fixed number of trials, 10 trials. Now what I'm calling success is being a defective part. This is what we call success. So success is relative, okay? It doesn't always have to be a positive thing, but it's what corresponds to the random variable x, and that's very important. So we already know probability of defective is probability of success, and that's 0.2. Okay. Here we have a fixed number of trials. We're inspecting 10 parts, so that one is good. Each outcome has one of two outcomes, defective or working. So we have that. Each trial is independent. I think that's reasonable because just because one part is defective doesn't automatically make the next part that's inspected defective also. Okay, and we have this probability of success fixed at 20%, and we have set up our random variable to be correspond to the binomial distribution. So we can use the binomial distribution to calculate x. So we are asked here to calculate the probability that the shipment is rejected. So reject shipment. We're told the criteria to reject the shipment is if more than 2 parts are found. Okay, well, there's a lot of scenarios that correspond to more than 2 parts. For instance, if I find 3, I would reject it. If I found 4, 5, 6, 7, 8, 9, all the way up to 10, that's a lot of outcomes of x to calculate. It's easier to do the complement. 1 minus the probability x is less than or equal to 2. Okay, so I need to calculate 1 minus the probability x is 0, minus the probability x is 1, minus the probability x is 2. And we're going to use the binomial distribution. Probability x equals k. Well, change it, I have probability x equals little x. Sometimes I do k instead of x because people find that less confusing. But this is calculated as n choose x times p to the x times 1 minus p to the n minus x. And in this scenario, n is 10, x is determined by the value specified in probability. Probability of success, which is being defective in this case, is 0.2 times by 0.8 to the 10 minus x. So if we're to finish this calculation and calculate this probability, it's going to be 1 minus 10 choose 0, that's 1, times by 0.2 to the 0th, times by 0.8 to the 10th, as the first one. Then 10 choose 1, that's 10, times by 0.2 to the first, times by 0.8 to the 9th power. And then finally, we subtract the last probability, which is 10 choose 2 times 0.2 squared times by 0.8 to the 8th power. And when we plug this into a calculator, we should get that this probability is approximately 0.677, or a 67% chance that we'll reject the shipment. Okay, so that was an example of using the probability distribution, or the binomial probability distribution, to calculate probabilities. In doing so, we had to use the complement rule, make sure that it corresponded to the scenario of a binomial distribution, which means I need to go through this scenario and make sure that each of these is a check mark. Then I can use the highlighted probability distribution.